In this video, we're going to solve literal equations. What I mean by that is we're going to solve for one variable that's in a formula, but there are other variables as well. So an example would be our common distance equals rate times time, usually written d equals rt. Remember that means r times t. So let's say we are going to solve for t. Well, pretend like d and r are numbers if you don't know where to start. So for instance, what if it had been something like 3 equals 5t, for an example? How would you solve this? You would divide by 5, right? But there's not a 5, there's an r, isn't there? So what we want to do is divide by r to isolate the t. And so we get d over r equals t. And usually when you're solving for a variable, you write it, the variable on the left that you're solving for. So this would be saying dt equals d over r. Right. So what does this mean? It means that if you knew the distance that you traveled and the rate you were going, you could figure out how long it took you, the time. The original formula, d equals rt, you would use that if you knew the rate and the time. You would multiply the rate times the time to get the distance. So for instance, take a practical example just so you can see how this would work. Let's say you knew that you went 30 miles per hour and you went 4 hours, and most of us would know that you went 120 miles, right? So let's say you only knew two of these things. Remember, this is the rate, that's the time, and that's the distance. I could see that r times t equals d, but let's say somebody told you only the miles and the rate, and you didn't know how many hours. So let's pretend you didn't know what the time was. So we have this formula, t equals d over r, and you want to find t. And so if you plug d over r, we would have 120 miles, right? And this is a little bit tricky. The rate is 30 miles per hour. So miles per hour basically means the hour would be in the denominator here, and when you multiply by the reciprocal, you would get 4 hours, which is what we had. So there's an example how you could use this formula, t equals d over r, to figure out the number of hours. All right, let's go on to another example. Another common formula is the interest formula. Interest equals principal times rate times time. And let's say you were asked to solve for r. Solve for r. All right, so it's a little bit tricky here because you see sort of the r in the middle of two other variables, but remember, it doesn't matter the order you write when you do multiplication. So it might be easier to think of this as p, t, r. So you sort of are thinking of this as the coefficient of r, similar to if you had something like this, 5 equals 7r, right? Except instead of a 7, it's a pt. Now what I'm doing over on the right, like I did in the previous example, is if you're not sure how to get started, you could think about having numbers in for all those other variables. So you would keep the r and then see, how would I figure out this problem? And you would do this by dividing by 7. But in this case, there isn't a 7. There's a pt being multiplied by r. So we want to divide both sides by pt. And that way the pt's cancel, and I get I over pt equals r. And again, it's easier to read it when you write the variable that you're solving for on the left-hand side. Okay, let's do another one. All right, here is another formula. This has to do with perimeter. 2w, w would be the width, plus twice the height, plus the length equals p. So 2w plus 2h plus l equals P, and we're going to solve for W. So first you find the variable W, and it's over here, right? And that's the only W. So basically you want to isolate the term that has a W on one side of the equation, just like if this was 2W plus 5 equals P. So we need to subtract 2H and subtract L from both sides, so 2W is on both sides. Just like if this was just plus 2, you would subtract 2. So let's do that. 2W equals, all right, so we're going to put that on the other side by subtracting 2H from each side and subtracting L. Now I'm not showing the minus 2H minus L on both sides of the equation. Hopefully you know that, if you subtract it on both sides, you're going to see that over there, right? On the right-hand side of the equation. Okay, we're close to being done. If this was 2W equals like 8, for instance, you would just divide both sides by 2. And you're going to do the same thing here. You're going to divide both sides by 2. But you've got this whole side to divide by 2. So you have to put the whole thing over 2. So we have W equals P minus 2H minus L all over 2. Now, some people might write this differently by dividing each term by 2. So it would also be correct, but just not all written as one fraction if you wrote P over 2 minus. Now, if you had 2H over 2, the 2's would cancel. So that would just be an H, right? And the minus, you would have L over 2. That's also a legitimate way to write the answer. You have to decide which looks in simplest form. I think the one I've put a box around, but they're both really correct. All right, let's do another one. SR plus TR equals U, and we're going to solve for R. All right, this is a little bit different because when you're looking for the variable R, there are actually two terms that have the variable for R. So think about what you would do is if it was something like 3R plus 5R equals 11, for instance, you would combine the like terms on the left here to get 8R. And how do you do that? You've got to add the 3 and the 5 together. And by the way, that's also an application of the distributive property. And that's how I usually like to think of this over here. You can either factor out R using the distributive property, or you could think of just adding the coefficients, which is S plus T. So either way you look at it, if you factor out R, it would look like this, right? And this S plus T is the coefficient. Or somebody else might have thinking, oh, I'm just going to add the coefficients. I'm going to add S to T and then write the R. Two students might write it either of these ways to be correct, depending on how you think about the problem. All right, I'm going to look at this second way, and it doesn't really matter. The trick is, how am I going to isolate R? I've got something times R. Okay, well, let's see. How would I have done it over here if I had 8 times R? I would have divided by the coefficient, which is 8. Well, the coefficient here is this whole quantity S plus T. So I have to divide by the whole thing S plus T. Now, on the right, I'm just going to put S plus T. You don't need to put that S plus T in parentheses. I did here so you could see how those are going to cancel. So I have R equals U over S plus T. And I've already got the variable on the left side of the equal sign, so it's in a nice form. It's another problem. Mn equals P minus Mr, and we're going to solve for M. All right, so again, notice we have the variable M in 2 different terms in the problem. So what I needed is to sort of do the combining of like terms, but they have to be on the same side of the equation first. So these 2 terms, the Mn and the Mr, negative Mr, need to be on the same side of the equation. So let's add Mr to both sides. All right, so I have Mn, I'm going to add Mr to both sides. Well, when I add it on the right-hand side, I'll be left only with P. Okay, now how am I going to combine these like terms? I can think of this as the coefficients of each m. I've got an n for the coefficient of the first term, and r is the coefficient of the second term. So if I want to just add the coefficients, I could write n plus r. That's how many m's I have. Or you could have gotten the same thing by factoring an m out and writing m times n plus r. Either way works. And again, that's just like a 5m, but instead of a 5, it's an n plus r, so we need to divide both sides by the coefficient. So we've got m equals p over n plus r.